All right, welcome all to this new session. This is basically we're talking about Excel basic financial functions, which eventually lead us to do so many things. Once we master this five basic functions and we know how to use them and where to use them. So these functions are this. I will come to these functions later, but let us understand what we are dealing with in terms of financial management when you're talking about Excel, right? So let us say Excel and finance. So see, we deal with broadly two things. One we call the present value. Now, what exactly is the present value? If you have to understand, it is we are talking about two aspects of the financial management. One is called the investment, that is, we are putting some money, to get back certain return from the money, or we are taking certain loans, what we call the financing, or anything else, and we are paying a cost of the capital back. So present value is normally at the beginning of this particular project, or we call the annuity, what we give or what we get at the beginning of the whole timeline that I am talking about. You can talk about the annuity, whole investment or whole loan period that we are talking. Right. Then we deal with something we call the future. Of course, you have a present value, then you have a future value. All right. And the future value when you are talking about is obviously when you, so it is exactly the reverse of the thing that we are talking about, right? So what we give or what we get at the end of the time. So if you've taken a loan, you are supposed to return everything, and at the end of the loan, you are supposed to return it. Or, if you have invested at the end of the period, you are supposed to get back something. Now, here also another variation in the present value have, you may do the whole investment at the beginning, or you may do a part of the investment at the beginning, and after that you do a periodic payment. And in Excel, we consider it should be constant over the annuity. Now, the periodic payment is like that. If you have taken a loan, you may pay it back in installments, or you may be making an investment in a recurring deposit, monthly basis you pay something. All right. Or if it's an investment, many times you may be, rather than getting everything at the end of the period, you may getting periodically getting back the return on investment on a periodic basis. All right. So that is what the periodic payments we can do if you are making an investment, maybe, or you are taking something else. Another factor that we need to consider whenever we are into a Excel in finance, we call the compounding frequency. All right, because it is the compound interest that is governing the whole transaction or period. Okay, so you will have an annual rate of interest, and that is actually the base of everything, or your investment and your. So you have an annual rate of interest that decides your return on the investments, and that decides the cost of the capital. But of course, the principle of mathematics that is applied is compound interest. So how it is compounded actually decides the eventual outcome. Because how the interest will be added to the principal amount that we are talking about. So it can be compounded on a monthly basis, it can be compounded. That is what we need to understand. It can be compounded monthly. So if it is compounded monthly, please understand the number of periods or periods or frequency in a year is 12. So it can be compounded monthly. It can be compounded quarterly. All right. It can be compounded quarterly. I'm sorry. It can be compounded quarterly. So if it is compounded quarterly, number of periods in a year is 4. Same it is compounded semi-annually. All right. If it is compounded semi-annually, then compounding period becomes 2. So what we have? We have an annual rate of interest. We have a present value that we are investing or taking at the beginning. Future value that we are getting or we are paying at the end. There may be some periodic payments that we make or we get, and there is something we call the compounding factor. And there will be compounded annually also. If it is compounded annually, that means the final one, if we say compounded annually, that means the number of periods is 1. It is 1. All right. Okay. Now, another factor that we consider is we need to calculate the number of periods that we call the NPER. The number of periods is the number of frequency that we are talking about. So, if the investment or the loan is of 5 years, let us assume the duration. This is the whole duration, whole timeline. If the duration is 5 years, see NPR will change accordingly your compoundings. So let me take this compounding here to make it understand. So if 5 years, whatever the rate of interest, it is compounded monthly, then it becomes NPR here will become 60. 12 into 5, 60 periods you have. If it is quarterly, NPR becomes 4 into 5, that is 20. If it is semi-annually, NPR becomes, for this particular case, 5 into 2, that is 10. And if it is annually, of course, it remains the year. Alright. So that means if it is 5 years, number of periods 5 years, if you are doing it annually. All right. So now another thing that we'll have to take into the consideration while we're into the Excel is we call the cash flow. There are two kind of cash flow that can be understood. One is an inflow, money which is coming in. So what money is coming in? Maybe you are taking a loan, money is coming in. Maybe you are getting a periodic payment, money is coming in. Or there is an outflow. So you're investing in a project, you are putting money in a bank, you are putting money in a cash deposit. Everything is an outflow. After that, if you are paying an installment, that's an outflow. You are paying a periodic payment for an investment rather than paying at the beginning. That's an outflow. So any outflow in Excel should be shown as negative. So we'll have to identify and we'll have to then put it as a negative value. Otherwise, the answers that will get is wrong. All right. So this is the basic premises based on which you are going to execute the 5 functions. The present value, what you get paid at the beginning of the financial transaction. Future value, what you are going to get or what you will pay at the end of the financial transaction. So this is about the beginning of the financial transaction. This is end of the financial transaction. PMT, as we said, payment made at each period, it remains constant over the life of the annuity. It won't change. Rate, interest rate per period. This is very important. It is not annually we are talking about, per period. One by period, I mean this NPA. This rate. Okay, and this is the NPA, number of periods. So you'll have to calculate the number of periods. If the annual rate of interest is given, we need to convert it into a rate per period. Okay, these are the syntax, so we need not really memorize the syntax at all. This is also the descriptions you can go through later. This is the cash flow that I talked about. So let us directly jump into some exercise and let's try to understand how to solve this. Now let us take up this particular problem. Let me take it to the Excel sheet. Alright, I go to the illustrate screenshot. I take this problem into Excel. So initially I will show you how to solve it. Later on you can graduate and you can do multiple things together, skipping certain steps. Because initially to get a hold of it, we need to understand that there are five factors that we are talking about. So what do we need to identify from a scenario? First, we need to identify the present value if there is in a present value in it. That we need to identify. To calculate the payment of a loan amount of 15,000. So it is loan will always come at the beginning of the financial transaction. So my present value is 15,000. All right. I convert it to a this. So do I have a future value in this case? Now, any loan that you take and you are paying a periodic payment, at the end of the loan period, your loan amount that you need to pay back to the bank should be zero in a standard condition. So, in this case, future value should be zero, then only you have completed the loan. Now, they have also given the annual rate of interest. Annual rate of interest in this case is given as 9%. All right. Duration in years. Duration in years it is given as 5 years. Now we'll have to understand the compounding frequency. So the compounding monthly they have said, so we can write compounding frequency or we can say period in a year, remember that. That is what is important. So these things we have identified from this particular problem. One thing that we have not identified out of the functions that we need to calculate is the PMT, that is the payment per period that you are supposed to make. In this case, that will be my installment. But before jumping into the PMT, we'll have to calculate few more things. That is what I'm going to discuss here. The things that I have to calculate is rate per period, if it is not given at all. Because here it is given the annual rate. So I have calculated the rate per period and also I will calculate what are the number of periods, that is NPER. How many periods we have. That means how many times it will be compounded. So compounding frequency in a year in this case is 12 because it is compounded monthly. So 12 times it will be compounded. So your rate per period becomes this 9% divided by your compounding frequency. That comes to 0.0. So you can convert it into a percentage. Now see, always remember if it is coming at 1%, no decimals. It may be an illusion, it may not be a 1%. So always it is better to increase the decimals to see the exact rate per period. It is 0.75%. Now NPR that you can calculate is, you see this is your duration in years and the compounding factor is 12. So you got your NPR, that is success. So basically we got all the provisions. This is PV is there, FV is there, rate is there, NPR is there. So any four factors are present. You can always calculate the fifth factor of the equation. And as I said, these are the fundamental five functions that we deal with. All right. Okay. So now what I'll have to remember is the function. That is what only we'll have to remember. So for payment per month, I have written it payment PMT. In your real times, you can write the payment per month on installment. I have written it so that I can identify what function I am supposed to use. So I am using here PMT. Now you'll have to follow the instructions which I call the palette. If you really do not remember the syntax and etc. Now you look at it is saying rate. Alright. So if it is saying rate, it is actually the rate per period. So you have already calculated the rate per period. You can click on the rate per period. Put a comma. Then it is asking for the NPER. You have already calculated NPR. Click the NPR. All right. Then it is asking for the present value. You calculate the present value. Now see the future value and the type that has been given. Type we will discuss later. Are optional. When it is under bracket, it's an optional. My future value is 0, so I need not really give it, so I can simply close it. I press enter. I get my installment that I have to pay is 399 rupees, and if you observe, it has come as negative because it's an outflow. Here it was an inflow because it present value I am taking a loan out of it. All right. So let me do one thing. Let me make a copy of this one, and I move to the end. I remove these things. I remove this one also. Let us take up another problem. So let us see which problem we are supposed to take. Let us take up this particular problem again and let us try to solve this with these parameters. Again, I come to insert. I come to the illustration, screenshot, screen clipping. Let us see what they say. All right. Now here they are saying us determine how many years it will take to save the 12,000 if you put 10,000 into saving account, paying 4% annual interest compounded quarterly. Now they are basically asking for duration in years. All right. So to calculate duration in years, you'll have to calculate the NP year. Remember that. All right. And so what I will do, I will take PMT here right now. I will take PMT here right now. Because that is I am not supposed to calculate. I take PMT here and I make here write a duration in years that is supposed to be my output and that I'm supposed to calculate. It will come from here. Now, okay, that is when I identify what am I supposed to calculate. So I calculate here, and if I calculate here, I can calculate the number of years. Now let us look at the present value. Determine how many years it will take to save 12,000 if you put 10,000. So you are putting 10,000 into the accounts. You remember it's an outflow. That's what you will have to remember. So you can put a negative sign here itself, or you can do it in the equation. I prefer to do it in the equation. All right. But if you forget it, you can directly put a negative sign here. Then put 10,000. Future value, because I want intend to get 12,000 after the end of it. So I put future value is 12,000. All right. Now, 4% annual interest rate. So it is 4% annual interest rate. There is no PMT mentioned, so PMT is 0. If something is not mentioned, we'll have to assume it is 0. It is 0 because there is no periodic payment. Compounding frequency, they said quarterly, so compounding frequency is 4. So I can calculate rate per period. So I calculate rate per period 4% divided by 4. I get my compounding period 1%. Now what am I supposed to calculate is the NPR. So of course I have the function, I type NPR. Alright, then I calculate the rate per period. PMT is not there. I can put another comma or I can select that cell. It's totally up to me. Putting a comma that means in null, then it is asking for the present value. Remember my present value is an outflow in this case. So I put a negative sign, then choose the present value. Then I choose the future value because this time future value is given. Type I am ignoring right now. Press enter. So this gives you NPR, number of periods. So if it is the number of periods, what are the years? Number of periods divided by the compounding frequency, in this case it is 4, gives you the number of years. Sorry, it is in the rupee, so I'll convert into 4 point cell. I'll convert into a number and okay. So this gives you what you wanted. The duration is 4.5 years or you can say 5 years. Alright. So again I move and copy, I move to the end, I pick up another problem. Alright. So let us see, I delete this, I here delete everything, I delete this. Let me pick up another problem. Alright. Okay. Now let us do this one quickly. I come to the insert, I come to the illustration, I pick up the data again, So here what they're saying is, alright, what they're saying here, if you read it correctly, calculate the annual rate of new Chevy Cruze that the cost of the car is 18,999 and you will put down 2,000. Now remember this, you are putting down 2,000. That means 18,999 minus 2,000, that is 16,999 is the loan that you are supposed to take. You will pay 350 per month for the 5 years. Annual interest rate is compounded monthly. And here you are supposed to calculate the annual rate of interest. So let me do one thing. Let me put here duration in years because the output should come here. Annual rate of interest. All right. Now here my present value will be, because I will take a loan for this, is 16,999. That we'll have to understand because 2,000 I am making a down payment. Future value, again, it's a loan, so it is 0. Duration in years, let us see what they have given. Car, you will have three path for 5 years. So your yearly duration is 5. Okay, I'll have to change it to numbers because earlier I did it as a percentage. So your 5 years, I put duration as 5 years. PMT you are paying 350 as installment per month. Remember, then it's an outflow. It will go out. Compounding period, monthly they said it's 12. So let us, and rate per period we'll supposed to calculate. Because once we calculate the rate per period, then you can calculate the annual rate of interest. Alright, so here NPR, let me calculate. NPR is your number of years and compounding frequency. It gives you 60. Now things becomes very simple. Here type equal to rate. I start the bracket. So it is giving me choose the NPR. I choose the NPR from here. I know NPR is there. Then it is asking for the PMT. Remember, it's an outflow. So I put a minus sign. Then I choose the PMT. Then it is asking for the present value. It's an inflow. I don't have a future value. So I can close it here. Press enter. You get 0.72% rate of interest per period. But you are supposed to calculate the annual rate of interest. So you click this one into your frequency per period. This gives you 0.9. You convert it to a percentage. So, and you increase the symbol. So it comes 8.65% the annual interest rate that you are paying. All right. So again, I move a copy. I go to here for another variation. Let us check. Let me delete everything from here. Delete this, delete this. Let me go back to see what other challenge they do. Okay, let us take uh, this one. All right, so let me see what I can do. Let me click insert. Okay, let us take the previous one. So let us take this one. I come to the insert illustration screenshot. I choose this one so that I can have a greater view of this one. So this is very much there. All right, now let us see what they say. My structure is there. I am having a very systematic approach of solving this problem. Determine how much money would you have to put into a cash deposit now to have a 5,000 down payment. Now, if you read it carefully, you immediately understood they are asking for this one, present value. Because how much money right now you are to put. So you keep it here present value because that is the output that you want to calculate. Here you can type it as a future value and here you can type as a annual rate of interest. All right. Ignore the colors right now because that has got no meaning. All right. So if I study it calculatedly, you want 5,000 end of the period. So that should be your future value. Right. And that's an inflow that you are talking about. Annual rate of interest is 3% annual rate interest. So you type 3% here and you convert it to percentage. Right, so it is giving you something garbage from itself. Let us go to the percentage, make 0. Okay, I delete it, then I put 3, so I get 3%. Duration in years, it is 2 years. PMT is not mentioned, so it is 0. not required. Compounding period yearly. Interest rate, annual interest rate compounded yearly. Basically, now you don't need to calculate, but still I am doing it. It is 1. So if it is 1, your rate per period is same as the original because you are supposed to divide it by 1. But still I am doing it for the benefit. And NPR, of course, the number of years is your NPR because it is compounded annually. So let us calculate the present value. I calculate PV. All right. Now let us look at rate of interest is this. Now following the process, NPR is 2, PMT is not there. Calculate the future value. So you get how much you have to deposit, 4712, which is of course an outflow that you will have to deposit. So it is coming in negative. All right. Now let us move on to another problem with a variation. All right. So you can do other problems also. The solutions are given. All right. Now let us take up this particular problem. It may seems a bit confusing, but let us do it. Okay. Let us give some space here. Insert. I come to the insert, illustration, screenshot. Let us take up this particular problem. All right. Here they're introducing a concept called the balloon payment. So calculate a monthly mortgage. I delete everything here. Calculate the monthly mortgage payment. So you are actually supposed to calculate the PMT. So if you're calculating the PMT, you can down these things. Monthly payment when you are supposed to calculate. Control C, you can put down here. You can make it present value. All right. Calculate the monthly mortgage that you are supposed to calculate. For a loan you have taken of 1 lakh. So you put your present value is 1 lakh and that's an inflow. With a balloon payment of 10,000. Now the balloon payment means normally what you said, whenever you have taken a loan, we consider your future value as 0 because end of the period it should be 0. But when you consider a balloon payment, that is an agreement between you and the bank. After the financial transaction period timeline, still there will be some amount to be paid to the bank. We want to keep the transaction until then. After that, we may do something. So here they said the balloon payment. So whenever you see a balloon payment in a loan, it is basically your future value. All right, first I'll have to convert it to a numbers. So I convert it to a number, format cell, I convert it to a number. So whenever you see a balloon payment, it's basically the future value. That end of the transaction you are supposed to pay to the bank, and of course, it is an outflow. We'll have to remember that. Annual rate of interest they said is 4%. So it is coming as 4%, no issues. I'm sorry, 4% annual rate of interest. Duration in years is 30. All right. Compounding period, they said it's a monthly compounding, monthly, compounded monthly, so it is 12. And last, now we follow the process. So your rate will be your rate of interest annually divided by the compounding period. It comes to 0.33%. Your NPR is definitely the number of duration in years is 30. All right. So let me first change its formatting. I right click here, format cell. I convert it to a number and make it 0. All right. So 30 years is the duration. So your NPR is 30 into 12. That is 360. So when it is done, simply calculating PMT is not an issue. You calculate PMT. PMT will be your rate per period, comma, your NPR, comma. Right, now you choose the present value, loan you have taken, that's an inflow, but right now you have a future value also, so you cannot ignore it. And that is a negative value because that will be outflow. Type you are still ignoring. So press enter. So 463 rupees is the per month payment that you will have to make. So that is becomes your installment. All right. So let us move on to the final exercise for this particular video. Another variation that we'll look after. Okay, I delete this everything. I delete this one. So let us take you to the final one. Okay. Just I want to show you a variation. That's why I'll take you to another problem. Just hold, give me 5 seconds. I'll pick up that problem and we'll try to solve it. All right. So this is the problem that I'm talking about. So let me come to insert, illustration, screenshot. Let me take this problem. Here, what they are saying, it's pretty interesting. You have a uh, you have arranged for a student loan from a local bank. The bank will make quarterly disbursement of 1,500 rupees. That's very interesting, actually. So no payments are made until the graduation. Although the interest charge is at the rate of 4.5% per year, compounded quarterly, then the final amount you will owe to the bank. So here we are supposed to calculate the future value. So let me make it PMT here. Now let us understand what they are asking for. Here's something they have written at the beginning of the period. If you read it very carefully, at the beginning of the financial transaction, there is no payment. So your present value for this one is 0. What you are getting instead? A periodic payment of 1,500, but they have said at the beginning of the period, that is the compounding period. Annual rate of interest, they say 4.5%. Alright, let me increase the decimal, it will show you 4.5%. Duration in years, let us see what they are saying. Assume the loan duration is 4 years. So I keep it 4 years. Compounded quarterly, that means compounding quarter is 4. Now let us calculate the rate as usual. So I calculate this rate is 4.5% divided by the compounding period, that is 4, it comes to 1.13%, and P year is equal to your duration in years into you are calculating the compounding period, you got it 60. Now you are supposed to calculate the future value. Now remember the present value is 0 because you are getting periodic payment instead of getting a upfront a payment. Alright, and you will have to pay everything at the end of the financial transaction. Now while calculating the future value, I first take up the rate of interest, that is this per period. Then it is asking for the NPR. I pick up the NPR. It is asking for the PMT. I am receiving this payment, so I click this the PMT. Then it is asking for the present value. All right, so I click the present value this time. It is needed because they said the money that you are getting at the beginning. If nothing normally mentioned in earlier versions, we have not bothered about the type, primarily because if nothing is mentioned, it is considered whatever the compounding is happening at the end of the period. And if you do not mention any type, by default, Excel will understand it is the end of the period. So we need not write 0 for the type. It assumes. But if it is the beginning of the period, we'll have to specifically mention in the type section as 1. Beginning of the period. Otherwise, the result will be problem. Now I click it and I press enter. I got, so this is the total payment that I'm supposed to make at the end of the transaction. Practice these things. I hope you understood it. Thank you very much.